A box is to be made of a piece of cardboard 9-inch square by cutting equal squares out of the corners and turning up the sides. Find the volume of the largest box that can be made in this way. For this problem, you're given that you want to be making a box from a 9-inch square piece of cardboard by cutting equal squares from each corner. Alright, so we're going to start out with a 9 times 9, and from each corner, we're going to cut squares, and we don't know what size the squares are. So we're going to be labeling those each sides as an X. So, what we need to do is now find the dimension of the green box, which is going to be the base of our square, which is going to be the base of our box when we fold the sides up. So each of those brown flaps is going to be folded up to make the box. So we're actually subtracting off X from each side. So the horizontal pieces would be 9 minus 2X. And then the vertical sides we're taking off X in both directions, alright. So we can do this would be 9 minus 2X for that side. So the green is going to be the base of our box. The brown flaps are going to be folded up to make the box. Alright, so our volume is going to be length times width times height, and in this case, the length and the width are both going to be the same. So they both 9 minus 2x and 9 minus 2x, and the height will be the size of the square, which is x. Alright, so we'll do a little bit of algebra. We're going to FOIL and distribute, and once you do the FOIL and distribute, checking your algebra, the FOIL part would be 81 minus. Then we're going to have negative 2x times 9, so that's 18 twice 36, and then plus 4x squared. Multiply that by the x, and you end up with 81x negative 36x squared plus 4x to the third. Alright, so since we're doing a maximum, we know that we need to find the derivative. So when we find the derivative, we'll have the form as 81 minus 72x plus 12 squared. We're going to set that equal to 0. So we'll factor out of GCF, and the GCF is 3. I will have 27 minus 24x plus 4x squared, set that equal to 0. Alright, so we can try to factor that, and it doesn't factor. So we have P prime is equal to 3 times 27 minus 24x plus 4x squared. Alright, factoring does not work, so we can use the quadratic formula, and using the quadratic formula, we put it into decimal as you can put it into any calculator, but there are the values that you get when you substitute into decimal, so we're setting this equal to 0. Alright, setting the derivative equal to 0 to get your maximum value. Alright, so we can either have 4.5 or 1.5, so let's go back to the original problem. And our sides are 9, negative 2x to our pole volume formula. So if I put the 4.5 in, then that doesn't make sense, because I would have 9 minus 9, I would end up with 0. So 4.5 is not going to work. Then 1.5 is going to work. So we can do the volume is equal to. So this one asks you to find the maximum value. Volume. The 9 minus 2 times 1.5. 9 minus 2 times 1.5 times 1.5. Alright, when you multiply all that together, you end up with 54. So the area is going to be, or the volume is going to be in cubic inches. Alright. Alright, if it asks for the dimension would be 6 inches by 6 inches by 1.5 inches. So this would be the dimension.